Hey, welcome. Today, we're going to demystify one of the real powerhouses of the programming world, C Sharp. If you've ever played a game made with Unity, used a Windows app, or browsed a really complex website, you've probably already seen what C Sharp can do. So, we're going to pull back the curtain and see how it all really works. Let's dive right in. So, have you ever been in the middle of a game or just using an app on your phone and had that thought like, how in the world does this actually work? What's holding all this together? It can seriously feel like magic, but behind all that, it's all about structure, logic, and having a really solid plan. And honestly, that's the best way to think about it for our explainer today. Let's imagine writing code isn't about typing weird commands into a black screen, but it's actually like building a house. And the language we're talking about, C Sharp, well, that's our blueprint, our bricks, and our mortar, all rolled into one powerful package. Every great building project, every single one needs a blueprint. It needs that master plan that lays out exactly what you're building and how you're going to do it. So let's start right there. What exactly is C Sharp? Okay, so C Sharp, and you say it's C Sharp, is this modern, super versatile language that came from Microsoft. It's the engine running behind a huge amount of software, especially anything built on their .NET framework. You can think of it as this trusted, really powerful toolkit that developers use to build solid Windows apps, dynamic websites, and yeah, even those incredible video games, especially with the Unity engine. Right. You can't just build a house on shaky ground. It's not going to work. You need a solid foundation. And in the world of programming, that foundation is built with data. So let's take a look at how C Sharp handles its most basic building materials. Now, here's a really important idea about C Sharp that sets it apart. It's what we call a statically typed language. So in our house analogy, this means your blueprint has to say exactly what materials you're using for every single part before you even start building. A wall is declared as wood, the foundation is concrete, period. It makes you plan ahead for sure, but it prevents so many costly mistakes later on. It just makes the entire structure way stronger and more predictable. So what are these basic materials? Well, we have a few fundamental types. You can think of integers as your numbers, the measurements for how big a room is. Strings are just text. They're the labels on the blueprint, like kitchen or bedroom. Booleans are your simple on-off switches, true or false, light on or light off. And then you get to objects. These are more like your complex pre-built parts, like a whole window unit or a smart home device, each designed to do one specific job really well. All right, the foundation is laid. Now it's time to put up the frame. This is what's going to give our digital house its actual shape and its organization. Let's see how a C-sharp program is all put together. The whole hierarchy makes perfect sense when you think about it this way. At the very top, you've got a namespace. Think of that as the neighborhood your house is in. Then, inside that neighborhood, you have a class. That's the house itself. Inside the house, you've got methods. Those are the individual rooms, each with its own purpose. And finally, inside each room, you have statements. That's the furniture, the appliances, the stuff that actually does things. Of course, a house is pretty useless without hallways and doors to connect all the rooms, right? In C Sharp, we call that control flow. It uses things like if-else statements, which are kind of like a locked door that only opens if you have the right key, and it uses loops, which let you do the same action again and again, like walking up a staircase. It's all about directing the traffic through your code. Okay, so we have a frame. It looks like a house, but it's not a home yet. It's not livable. We need to install the core systems, the plumbing, the electrical wiring, all the stuff that actually makes it functional. And the main idea here is something called object-oriented programming, or just OOP. The idea is, instead of building everything from scratch, piece by piece, OOP is like using high-quality, prefabricated modules. Each module, or object, is this self-contained unit that has its own data and its own functions. It makes building huge, complex applications so much more manageable. The first big idea, or pillar, of OOP is encapsulation. Just think of it like the walls of a room. What happens in the kitchen should stay in the kitchen, right? Encapsulation bundles everything a component needs together and keeps it safe from the outside. It's all about privacy and keeping things secure. Next up, you have inheritance. Imagine you have a fantastic master blueprint for a house. Well, with inheritance, you can use that same blueprint to build another house. But maybe this new one has an extra bedroom or a bigger porch. You get to reuse the core design while adding your own unique twists. It's incredibly efficient. And the third pillar is polymorphism. I know, it sounds super complex, but the name just means many forms. The idea is actually simple. Imagine one single light switch on the wall. That one switch could turn on a lamp, or a ceiling fan, or maybe the outdoor lights, all depending on how it's wired. That's polymorphism in a nutshell. One single command can have many different outcomes.
And to round things out, we have a couple more essential systems. We've got collections. These are basically the closets and pantries of your code, places to neatly store groups of similar items. And maybe most importantly, we have error handling. This is your house's set of circuit breakers. If one appliance overloads, it just trips a breaker for that one spot instead of taking down the power for the whole house. It's a lifesaver.
So, we have the blueprint, we have the principles for building, but any good builder also needs the right tools for the job, and they have to follow the local building codes. So let's open up the developer's toolbox. In the C# world, your main toolbox is called an IDE, like the famous Visual Studio. And this isn't just one tool, it's a whole suite of power tools that help you catch mistakes, write code way faster, and manage your entire project. Then, alongside those tools, you've got best practices. Think of these as the building codes that all the pros follow. They make sure your digital house is stable, secure, and easy for someone else to come in and work on later. And that's really the whole point, isn't it? Following these principles and using these tools doesn't just get the project finished. It lets you build software that is robust, that is efficient, and critically, that's easy to maintain and upgrade down the road. You're not just building a shed, you're building something that's meant to last. So, there you have it. We've seen how C# gives you this complete blueprint for building some truly incredible digital structures, all the way from the simple data that forms the foundation to the complex systems that bring it all to life. We've shown you the plans. Now the only question is, what will you build?